Good morning. As Jeremy was describing, I am the engineer director at MLS Listings, and I have a team of 15 engineers who are working on different projects that we're managing. Sergey here is the solution architect from Intel, and we have known each other from various different meetings. I had a fortune to attend his previous tasks, and he's very passionate about deep learning. So,
thank you.
So just to give you some background on this project, I think we were discussing this not more than a month ago, and trying to figure out what is possible. And we were having discussions about figuring out a way to use big DL with MLS listings. Intel was looking for media that they could use to train their models on. And out of that, we currently aggregate a lot of data from other MLSs, and we have over 10 million listings in our database. Each listing has at least 25 to 30 photos. So we have a lot of media that I think Intel could use to do the training process. And Sergey, do you have something to mention here?
Sure. We've been talking with Ashish and Dave for a while about what can we possibly do with, in terms of image recognition and deep learning, and gradually we kind of converged on this POC. For anybody doing deep learning or machine learning, it's clear that the biggest problem when you try to do it is getting good data. Because in the end, 80% of your time in machine learning is spent locating data and cleaning it up. And MLS Listing has the best data out there. It's curated, it's clean, it's humanly verified. It's the best data set I've ever had to work with. Almost zero data engineering that needed to be done on our side. It's all done by MLS Listings. So that was a perfect opportunity for us. And for the second part, why I was really excited to work with MLS Listings, aside from working with excellent engineering team, real estate is easily understandable by everybody. I mean, I get up on stage and I start talking about some commercial propensity modeling and merchant consumer behavior, and people go to sleep. I start talking about buying and selling houses, and everybody is awake and, yeah, we know. So that's why we're so excited about this project.
Yes, so one day I was at my office, and my boss, Dave, he walks in, and he's like, hey, Ash, and this is how it is like working with Dave, who is the CEO of MLS Listings. He walks in, hey, Dave. Dave says, it's like, Ash, I was looking for a house in Santa Cruz, and my wife were looking at this really nice house with a cool bathroom, and we were thinking, wouldn't it be cool if I could also find the other listings that had the same bathroom? And I was like, yeah. So I know he was coming up with a story, which could be real, but he also had met Sergey before he came to my office. So I knew what he was talking about. So he started discussing the possibilities of working on a POC with Intel. And while he was talking, I had all the scenarios going on in my brain with all the data share projects that he's been signing up. He has contracts coming in every other month to aggregate more data from other MLSs. We are also working on OData APIs to put them in production. And while we're doing it, we're also in mid of migrating our softwares or our projects to Azure. So we're in cloud migration. We also have a new website coming up. So these engineers are booked for full time, and where are the engineers for POC? So I didn't say anything. I was like, okay, let's go talk more about it. So Sergey and I started looking into the possibilities. How could we do this POC without needing my engineers hours of hours spending on implementing the POC? So first thing that came out really handy was the OData media APIs, because they were already in production. So Sergey said, I need the images. And I said, OK, can you connect to my OData API and pull the images that you need and get your training started? So he said, no problem. He had engineers. He said, I'm gonna put my engineers to work, and we're going to start training the data sets. And I gave him a token, and he connected to the APIs and then started working on it right away. While he was training, he also got Microsoft involved. And what was Microsoft's?
So Microsoft has this Azure platform offering, and they're going machine learning and deep learning everywhere in a big push. I've never seen any company out there, including Google and Amazon, just go machine learning, deep learning on all fronts, starting from your Excel and Word application all the way to 1,000 machine clusters. And they have a team right there in Sunnyvale in Moffett Towers, a team of data scientists. And when I reached out to them, they said, great, we want to help. We'll give you Azure resources. How much you want? $1,000 a month worth of compute resources? You got them. Great project. We want to be involved, run it on Azure, and use our data scientists if you have any questions as consultants. So that's how it was actually a three-side partnership: MLS Listings, Microsoft, and Intel.
Yeah, so then we started the process of having our weekly meetings, our updates. We did face-to-face meetings at Microsoft's office, at MLS Listings office, and all the engineers, they started talking about like how to do this and what can we achieve. My goal was to do something end-to-end, and Dave also put some extra pressure on us saying, hey, Rezo is coming up, let's go show it to the Rezo members, and let's see what we can achieve. So we were throwing lots of ideas. We had tagging. What was your team talking about?
Well, it was mostly data science talk. We were thinking how to do the image similarity. So we were discussing a lot of ideas how to structure the model, how to build a neural network, and that sort of thing. David was he really wanted to be able to do this contextual image search. So I like this bathroom, plop it in, show us what other houses have bathrooms like that, but we never quite got there.
Yes, so, and his team members were also looking into tagging. They were saying, hey, we can find out all kind of things, what's in their image, and we can put that and put it into your listing data. And when we were talking about, I also had this 2 weeks timeline that we were supposed to be done with this POC. So we agreed on having an end-to-end with the bare minimum that could be achieved to show that the big DL is the correct platform, and it can work and provide the kind of features we were looking for. So, so what we did was basically, my team is working on our new public website, and this is what it looks like. It's using internally the same OData APIs that our data feed customers are using. The interface is built using Microsoft.NET, and we're hosting it on Azure. And at the same time, Sergey secured resources for his big DL platform. They downloaded the images, trained everything, and your team said it took about 2 hours to train on 10,000 images to get this model ready. Is that correct?
A bit longer than that.
A bit longer. So during that time, they deployed their process on VM scale set, so it could scale up to how many? Hundreds? Or how many scale sets did we use to train?
We had thousands of images in the training. I'll go into the details.
So they ran this, and we were while we were doing it, we were also calculating the cost. Like how much money do we need to actually get this setup ready? And we were accounting for every single resource that was being used. So internally, the big DL was hooking up to the IDX payload, pulling the media out, and they started recording all the features into their data sets. And my team started working on the front end, And we are trying to figure out like what would be the best API interface for us to implement. And because we didn't want it to be too complicated, we said, okay, you give us an MLS number. So Intel's team needed just an identifier for the listings. So we provided an MLS identifier to Big DL team, and they looked up into their database for that MLS ID, and then in return, they gave us top 5 listings that would match the similarity features. So, and that was the interface like. So we started working on it, and finally, this is what came out of it. So we have a property detail page that a user would be looking at, and that page is communicating to an API that is implemented on a big DL library. And so every time a listing image is uploaded, the machine learning pulls that image and caches it on its end. And our API is basically communicating with it to get the top 10 or top 5 listings that matches the listing that the user is looking at. And we decided for this POC, we're just going to look at the front of the house.
Yeah.
Right. So we were not ready to go down to every single image. So we just wanted to make sure that it's simple enough and it's end to end. It does the whole loop. So this is what started to look like. It had the image that the user was looking at and other possible houses that user could look at. So there were many more discussions, like how do we narrow it down to users' criteria? And I was like, would it be possible? And him and I were having those discussions. We were trying to figure out how will we make it possible to match to users' criteria, which turned out not to be a big deal because all we had to do was add extra filters to the API, and then it would narrow it down to the same price range, same size of the house, and same kind of locality that user was searching in. Yep. So those are the things that we'll be working on in future, but here are a few screenshots from the POC.
We can probably just go to the
and
demo.
now,
so while Ashish is setting up the live demo, you may all be wondering why is Intel interested? I mean, I'm interested, but why is Intel interested? Intel is in the business of selling hardware, the chips, the servers. So the more of these projects we do, the more Azure compute resources are needed, and the more Intel servers are being sold. And that's what pays my salary.
So this is our new website that my team has been working on. And as I said, we're using OData APIs to build this interface. Some of the things we were able to work on is like providing, we're trying to improve the search experience for the user. And we tried to do this auto-suggest where, when user is typing, we're trying to find something that is related to their search criteria, so it's automatically suggesting the things that user could search on. Users are running their searches. We're using the filters from the API to narrow down.
I haven't seen this page.
The search results. Let's look at some nice houses.
So basically, at the high level, what we're doing here is we're improving the user search experience, where in addition to the house they clicked on, we provide them an option to look at a few other houses whose front resembles what the user liked, within the same search parameters, the geo area, the price range, the number of bedrooms. We just say, hey, you like this house? Maybe you want to look at the other 5.
Yes, so in this case, let's say if user was looking at one of the houses. So what happens here is that when he opens up this listing in real time, the API call receives these similar homes that matches the features that the user is looking at. And it's all happening in real time, so it picks up the top 5, and we just project it on side by side. So you could see that there are some attributes in the house that the big deal is looking for. It's like what is around the house. There are some trees. So all these pictures that start to show up have the similar features that the big DL machine learning process is recognizing, and then they're providing the feedback to the front end, saying, hey, if you are looking at this house has similar features. It's a 2-story here, 2-story here, some open area in the front, and you can see how some of the results are really good, because if I am looking for a 2-story house, this could be the other one that might match. So we
and this concept could easily be extended to looking not only at the front of the house, but at every image that's attached to that listing, like bedrooms, bathrooms, kitchens, whatnot, and do a more extensive comparison. The work is the same. The model would be the same. It's just more compute and more work.
So this all turned out to be like very little work for us to integrate with a service like this. All we had to do was just make an API call, provide a listing ID to the API, and in return it provided 5 houses that were similar looking to the house that our users was looking at. So this was a pretty good output for us. In 2 weeks we got these results, and we said, yes, I think this is a great thing. It can be demoed to the RESO, and it took me, I think, less than a couple of hours to run the end-to-end test and show that it was actually working out really well.
Putting the front end onto it and hooking up the API was a breeze. I was worried. Usually, in my experience, that takes a lot of time. No. The API was very solid, and we got it done very quickly.
So,
all right.
With that, let's go a little deep dive and see what's going on in the machine learning area. So Sergey did send me another slide. I reviewed his slide before these slides came out. The first version that he sent was more big deal, a lot of equations in it, a lot of processes, and I was like, okay, this is not what we need. So let's work out something that we can actually communicate. And
right.
And these are more simpler slides for us.
Thank you. So just to step back a little bit, so what the POC has, it actually has, it's all running on Azure cloud, right? It has 2 services, 2 servers running. One is Ashish's MLS listing server, which communicates with our Azure service where we run the deep learning part via the API. So we actually have 2 coordinated services running here. So I'm going to step back and give you a little bit of an understanding of what's under the hood in that big blob, that's the deep learning in one of the previous slides. Machine learning, deep learning, artificial intelligence, whatever we call it, usually consists of 2 distinct parts. One is called training, and another one is called scoring or testing. Scoring and testing is used interchangeably. Training is where you take something that usually is known, like images that you know that it's the front of the house, and you train this magic deep learning model to understand what it's looking at. And then when it's all done and converged and happy, you move on to the second phase where you throw an unknown image at the model and say, OK, now tell me what it is. So that's a scoring. So this is the training part that you're looking at. On the left, we created a labeled, meaning numbered data set of real estate images. We just basically used Bing search and said, OK, show us all the houses that are of colonial styles, and boom. So we grabbed all them and marked them. OK, these are all colonial style houses. Now show us all the two-story houses. Boom. OK, these are two-story houses. Now show us all the houses with stone front. And there you go. And we built this massive data set. Then we took this big deal deep learning framework. And it is a framework that allows you to build deep learning models. There are, by my last count, about 60 different deep learning frameworks out there. Ours is one of the few that runs on distributed multiple servers. And this is very important because if you cannot build something and productize it if it runs on one machine, and if your data exceeds the capacity of one server, or if your compute requirement exceeds the capacity of one server, you can't do anything about it. I cannot tell you how many customers I go to, big customers like Walmart, Target, and they say, we have data scientists. They build these wonderful models. They work great. Our problem is they only run on one laptop. And now we have this huge data, and they cannot be scaled. So we need to basically throw away what we've done and go on to a large distributed system. So Big DL is built from the ground up to run on Apache Spark, and you can scale it from 2 machines to, we tried it on 1,024 machines. So you just elastically scale this solution to the needs of your compute, to your compute requirements, and to the number of images that you're processing. So we took this labeled data set, and we built the model, this VGG architecture, and it became this blue box on the right, which is a trained model. So important in the training process is this. And that's true universally for any machine learning or deep learning application you try. Long compute, we're talking about hours and days. Huge compute resources, 60 nodes, 28 cores per node. The model parameters of this box on the right, the blue box, they're constantly changing as you train. The model is constantly learning. And you do it many times over until it converges. You periodically test whether the model really predicts that it's a 2-story house, and you change a few parameters, and you start doing it again. That's all the bad news. The good news, you do it once. So you incur this upfront cost of building the model, and it's done, and you don't need to touch it again. Let's see if this thing works. Yeah, it does. So once it's done, you move on to the scoring phase, where, as I said, you take an image of a house on the left, and you throw it into the front end of the model. And out comes thing that's called feature vector. It's literally one long string that has that tells you whether it's it has multiple entries. The first one is, hey, is it a bathroom? Is it a bedroom? Is it the front of the house? The second entry in the vector, hey, what kind of style of the house is it? Is it ranch? Is it colonial, Victorian? How many stories it has? And by the way, we picked the structure of the vector arbitrarily, but for the content, we used the terminology and categories that you good people created for us. So we didn't have to figure out and be creative what to call the house. It was ranch or Victorian or colonial and so on. And the last of that part of that vector is 25,000 long string of numbers. And those are just, they're not humanly understandable or comprehensible. These are just latent features of the image of the house that the model extracted and stored. And the model basically converted the image to the string of 25,000 features. And the model knows that when it sees the same string of 25,000 features next time, it's going to be this house. Right? It's important to understand the model, deep learning model, does not store images. It does not even store these feature vectors. The way it works, if it sees this 25,000 features later, it will know that it's a house. Okay? And then putting it all together, just rehashing. First we do the training, and we get the model. Then we don't change the model anymore, but now we add images one by one, and we get the feature vector out. So this is a 5-minute explanation what is machine learning or deep learning all about when it comes to images. So now the green boxes here are what Ashish's team put together. So we have the listing images. I'm sure somewhere there is a pointer. So this listing images, via API, we get them into the front of the trained model. So these are the images that you type in the zip code in the demo that Ashish showed, and out came 100 images in the 95123 zip code. So we get all these 100 images to the front of the model, one after another one. In fact, they're processed in parallel in a batch, and out come 100 feature vectors. 100 unique feature vector, one vector per image, one vector per house. And then user, meanwhile, clicks on a house that he or she likes. And out comes another. Where is the pointer? There's got to be a pointer here somewhere.
The center button is the pointer.
Oh, center. No, it doesn't. Doesn't work. Anyway, out comes another image, which we also throw to the front of the big deal model, and out comes this purple feature vector. So now what we have 70 features or 100 feature vectors of all the houses that are in 95123 area code that match the geo criteria, the cost, the bedrooms, whatever user entered in the field. And we have the one that user likes. And now the job becomes very simple. We just need to figure out which one of these feature vectors most closely resemble the purple one. And we use this thing called cosine similarity, which is basically a cosine distance between these two vectors. And out comes this 100 long vector of the cosine similarities. We sort it, and we chop off the top 10, and we feed it back to Ashish over API. And he displays it on the right-hand side. It's really conceptually that simple. You take your 100 images that fit the search criteria, you process them, you convert them to feature vectors. You take one that user clicked on, process it, get another feature vector, and then you search through them, see which ones mostly resemble the purple one, and you rank them. It looks very simple. It took us half of the time spent on this project was experimenting with different approaches. We tried things like called Siamese Networks, which I built before, where you literally, you don't do the feature vectors. You just you build two networks that run in parallel, and you just feed two images in it, and they tell you whether or not they're the same or not. Didn't work. It was too long, didn't work. Then we tried triplet similarity. And then finally we converged. You know what? Let's not build one giant model. Let's split the job. Let's do the comparison on just the feature vectors because it's going to be real time. Ashish wanted to do it to all be done in 1 second. So we quickly realized that even in scoring, we cannot do real-time scoring of multiple images. So we had to resort to the feature vectors and cosine similarity comparison. So this is, again, kind of putting it all together. It's a combination of the two previous images. We train the model, and then the same model gets applied to listing images and the one that user clicked on. Any questions on the deep learning part, or any questions whatsoever so far?
How much data comes out of this? I mean, obviously, somebody's storing all these vectors, and you've got millions and millions of images in a store. So, I mean, you've got obviously large amounts of data at the end of the day.
Actually, the data that we get in the end of the day is not that much. This, where are the image vectors? These image vectors, they actually don't take that much room to store. It's probably less than the amount of memory that it takes to store a couple of JPEGs, because these are just these are Python 9P arrays. They don't take all that much room to store. The The bigger storage required is this labeled data set, because these are like, I think, 10,000 or 100,000 images that we trained the model on. So that's probably by far the largest storage requirement.
But once the training's done, you can throw that data set away, right?
Yeah, but it's such a valuable data set. But you do not need it, yes. You do it once, and you do not need it. You may go back to it if you say, well, now I also want to look at, I don't know, look at three-story houses, or look at some other features, or sort by some other features that I haven't sorted it before. And then what you do, you add to this training data set, but you don't start from scratch. It's a thing called transfer learning. You take what you already, the model that you already built, and you just slightly modify it. Yes, please.
During the training, are you training JPEG images of interior features or just exterior?
Just exterior. We decided to simplify it. We could do it all. We actually trained. We created the image database of interior features as well. But then we decided to scale back and simplify it. Yes, there was a question somewhere here. No? Yes, please.
How many features did you train your training set? I mean, you said two-story. And how many other features did you have for exterior of the house for the training set?
So what we did a combination there. We created what we called classes. We created what we call tags. And then we let the machine infer the 25,000 features. So the classes and tags were type of the house, how many stories, that sort of thing. And then the rest was inferred by the machine.
How big was your data?
It was about somewhere between 10,000 and 100,000 images. Yeah, it was a manual work. I'm not going to downplay it. We just had people spending a good portion of their day doing Bing searches and grabbing images and storing them and labeling them. Didn't have to be a Bing search. We could have done it on MLS listings. It was easier because you enter the search parameter and that becomes your label, like colonial house, and then you have all the colonial houses out there. One more question. No? OK. So a few words about the infrastructure that we run it on. We run it on Azure. They have this offering called Data Science Virtual Machine. It's a nice thing because you do not need to know much about your servers and clouds. You just instantiate the machine, and you deploy your Spark in it, and then you install a big deal, and you're done. Azure has even a more simpler thing called HD Insight, where it comes pre-installed with you. You just need to start computing. That's a great thing about Azure. They have this offering that spans the entire range of engineering expertise. If you really know what you're doing, you get bare metal Ubuntu machines, and you build your own cluster and do whatever you want. If you know nothing about Spark, you take this HD Insight Spark distribution. It comes with a pre-installed version of Spark, gives you a nice GUI dashboard, and you just start coding it. It's a wonderful platform altogether. There was a question in the back.
Yes, before. What about accuracy, precision, and false positive? You have mentioned anything at all?
The accuracy of this model is in the high 80%. Like 85 to 88. Of course, there are some false positives and false negatives. That's a fact of life. But the point is, it works. If you give top 10 houses, and only 9 of them truly look like what you're looking for, and 1 is not, it's not a big deal. Not for this. This is not a mission-critical application. So engineering team. On Intel side, it was me plus 2 other engineers. One was true data scientist, and he was on the project about 50% of the time. And we had an engineer who was skilled in Apache Spark and was also able to work with API efficiently. And
And yes, for MLS listings, it was very simple. We just needed somebody from the API team to support Big DL team to let them access to the API. Of course, we had to build the API, so it's all done on OData. So we're reusing the existing framework. We never had to develop something new to support this. And of course, the front end was integrated, so we needed somebody with front end expertise to be able to link the API calls to the main page. And they are just C#, HTML, JavaScript developers, not a big deal.
And just to add a little bit on the resources, I mentioned before that we had like a huge cluster of 16 machines with 28 cores each. Please understand that this is the beauty of parallel infrastructure. I could do it on one machine. It would just take me a week to do it. Or I could throw 16 machines with 28 cores to do the training, and it was done in a matter of a couple of hours.
And Azure is very helpful because you don't have to pay for these resources if you're not using them. You just scale up and scale out, and then when you're done training, just scale down. So
you just have to remember to stop your machine, or you'll wake up to some large bill in the morning. It's open source. Big DL is not an Intel product. We developed it, as I alluded to, in order to promote the sales of Xeon servers. But Big DL is fully open source. It's community supported. People contribute to it from all the countries. Nobody owns the model. It's available.
Yes. So where do we want to go next? And this is the main reason we used Big DL. We went with a custom implementation because we wanted to make sure that anything that comes out of this project would be specific to real estate. We wanted to use something that was built for real estate related images that had houses, features related to what users were looking at in real estate industry. So these are a number of things that we've been talking about that we want to go, look next, and then explore more. There had been so many conversations, brainstorming sessions to figure out like what all will be possible in next few months if we continue to evolve these POCs. And these are the few things that are already in line to go and explore further and improve this POC and get it production ready as quickly as possible.
Right. So my experience is that the deep learning and machine learning is so powerful that once you do one POC and whet people's appetite, the opportunities are endless. You do one, and then in the process of doing one, you have 3 more good ideas lined up for execution.
So any final questions?
So, MLS data includes, both textual data and image data. If you try to correlate both of them at all, like if you're from image, you're saying it's a 2-story, that could be part of a description of some of the field. So, did you try to correlate both of them and then track the images?
We did not, but one of the things that's on the list here is doing exactly what you described, basically verifying if the comments of entered in the field actually correspond to the images.
Any other questions? So thank you so much for listening to this very professionally.